In the final set of slides, I'll talk a little bit about how these hazards lead to accidents. And I start out with this by talking a little bit about accidents. We typically talk about accidents, we see kind of two categories. On one end, you have the component failure related accidents, which means that multiple systems fail at the same time or fail sequentially or cascaded failures. And on the other side, you have the system accidents that are related to the fact that there are some errors in the interfaces between different components. For example, a flight crew may misunderstand what's going on with the automation in aircraft, or may misunderstand what's going on in terms of failures of the systems. So this fact that the human is not informed enough, who doesn't have all the information or misunderstands the available information, may actually cause an accident. Let's look at one of them. Let's look at the Turkish Airlines flight in 1951. This crashed near Amsterdam Schiphol International in 2009. It was a catastrophic event. The complete hull was lost. 5 passengers were killed, and all 3 pilots were killed. So what you see in this case, this cascade of failures, or even the system set of failures, resulted in a catastrophic event. Okay? So in this case, if you look at the accident report, the primary cause was a pilot error, and the secondary cause a faulty radio altimeter. So what you see is the radio altimeter failed here. It failed to perform its intended function, and that, together with the pilot not taking the right action, not interpreting all the information in the correct manner, and then also making the right decisions, caused the accident to occur. It's a very complex system. It's never just one thing that goes wrong. And in this particular case, of course, the radio altimeter is connected to a variety of other systems, like the instrument displays, the auto throttle, the autopilots. So the pilot was provided with a whole set of erroneous information. This caused the accident, more or less. There's also a lot of software-related accidents, and these are typically associated to flawed requirements that are just incomplete, or they actually make use, they're based on wrong assumptions. And wrong assumptions can be related to the computer performance, or the environment, or the operational scenario that this is being used for. So in other words, the software requirements were already wrong. That means that the people that actually do the programming, that making the code based on these requirements, then that code's never going to be any better. Yeah? So even though this, and that's what I say in this third item, even though the software may be highly reliable, if it's still based on these erroneous requirements, dangerous situation, accidents may occur. An example is the Ariane 5 Flight 501 failure. This was an accident, complete loss accident due to wrong guidance and information. 37 seconds after the start of the main engine. So what you see is that there was a specification and design error in the software of the inertial reference system that caused this to happen. And then what you see is, like, after the fact, when they analyzed this, they said, well, there was not sufficient analysis and testing done on the software based on these requirements to actually check out, to find this problem. Now, basically, there's, if you look at safety systems, we're going to focus mostly on safety critical systems, not too much on the other two. Safety critical systems are really systems where a system failure error results in a specified level of loss. So via hazard 2 accident.